in the yesterday class. Just again repeating that for 5 minutes. It is schema refinement. The schema refinement is nothing but whatever the schema, nothing but table or relation, if you are prepared, that is not going to satisfy. Means if it is going to miss any data or any particular column or any other extra fields, if you want to require or modify or delete, if you want to perform, that is called as schema refinement. Again, reanalyze if you are missing anything, and again you have to reform the relation. That is called schema refinement. When you want to perform the schema refinement, we have decomposition mechanism. Here, why schema refinement is required? Only because of the redundancy, we have the schema refinement. Redundancy is the big problem in our database management system. So that we have to avoid the redundancy, so that we need a decomposition mechanism to solve the schema refinement. Here now, what are the problems will come because of the redundancy? Basically, 4 problems. There is here memory, means storage problem, and insertion anomaly, deletion anomaly, and updation anomaly. Means it is if the redundancy is more, then insertion will take the problem, memory is the problem, unless you are storing same data, right? And deletion, when you want to delete, it is going to delete related documents or related records, and updation also it will delete. These are the problems. So that we need to avoid the redundancy. If we want to avoid the redundancy, we have to decompose the relation. If we are decomposing means, that is the schema refinement. Okay, these are the interrelated things. Okay, then when decomposition means, we have to divide the table into multiple tables, multiple small tables. That is the meaning of decomposition. Decomposition is dividing the table into multiple tables. How to divide? So when we want to decompose a relation, we must find the functional dependency. Means some of the attributes are depending on other attributes. Here, if Y attribute is depending on X attribute, that is called as X determines to Y. Means it is a functional dependency. So based on the functional dependency, we are going to divide the table into multiple tables, or divide the relation into multiple relations. That is called as decomposition. Always decomposition is depending on the functional dependency. Decomposition is going to solve the redundancy problem. So when we are going to perform this decomposition, we have to solve the schema refinement. So this is the interlinked side. Here now, when we want to decompose a relation, when we want to decompose, there is a 2 problems of the decomposition. Here, anyway, when you are going to decompose a relation, there is a chance of the problem. Here, one is, you need to ask yourself 2 questions. Especially, I told you the last class, very important. When you want to perform a decomposition using normal forms only, we can perform. Every normal form is having one particular functional dependency. Basic functional dependency today we are going to understand. Tomorrow onwards we will discuss about the normal forms like that. But first of all, what is functional dependency? We will discuss. Before that, I told you yesterday, when you want to perform a decomposition, you need to ask 2 questions yourself. One is before decomposition, another one is the after decomposition. The before decomposition, what is the question? The before decomposition, here that particular relation is suitable for decomposition or not. So this is very important. Means when you want to decompose a relation, decomposition means already you know very well, correct? Yes or no? All of you know, right? Are you following? Hello? Hello? Is this my voice is audible?
Yes.
Yeah, everyone knows decomposition, right? As yesterday I discussed about it. Response is required. Again, this is the problem I told you. Hello? Everyone is understood decomposition or not?
Yes.
Now, when you wanted to perform a decomposition, you need to ask two questions. Tell me what are these two questions? Yesterday itself I discussed them. Anyone, please. What are the two questions we need to ask ourselves? So I told you very important. Don't simply watching movie. Please, response is required. What are the two questions we need to ask ourselves? Hello. Respond. Gayatri, tell me rule number 511. What are the two questions we need to ask ourselves when we are going to decompose a relation? Miss Gayatri, 511. Saurabh, 528. Means no one is responding, means you don't want class, right? Hello?
Questions are like, do we need to decompose it, or the next one is, will we get any problem by decomposing the image?
Yeah. You must ask two questions yourself. One is before decomposition, that is, that particular relation is suitable for decomposition, means which normal form it is suitable, directly I tell you, which normal form. That relation you need to identify that. As a developer, as a database administrator, as a database designer, you need to identify that relation is decomposable or not. If it is decomposable, which normal form it is suitable. So that is the first important thing. If you are not identifying that relation is related to which normal form, then we cannot solve the problem. Because here in DBMS very clearly normal forms are going to help a lot to design the database. So that first question, we need to verify that particular relation is suitable for which normal form. Means it is suitable for decomposition or not. Because some of the relations it is not possible to decompose. Already I told you that we cannot solve 100% avoidance of the redundancy. Maximum we are trying to avoid the redundancy, but we cannot remove completely redundancy from the database. It is not possible. Because some data is there, common data, one person to person. That is what we cannot solve. Now the second question is, so okay, we are identified the particular relation is suitable to particular normal form, so that we are applied and we are decomposed the relation to two tables. So the second question, after decomposition, then we need to check yourself. Here, that particular decomposition is happened. Is there any problem after decomposition? Is there any problem? There again, two things we have to remember. After decomposition, you need to verify. One is lossless join. Another one is the dependency preservation. Dependency preservation and lossless join. So these are the terms we need to verify after the decomposition of the relation. If these two terms are not satisfied, again you use the original relation, don't decompose the relation. Because if it is, first one is the dependency preservation. What is the meaning of dependency preservation? That means one table is depending on another table. One is the source table, another one is the foreign table. Already I told you, means same, at least one column must be, when we are going to decompose, at least one column must be same in the both the tables. So that here the dependency preservation will come. Correct? Yes or no? Yes or no? Hello? When we decompose, we need to use one attribute common in the both the tables, so that we will get the dependency preservation. Yes or no?
Yes, sir.
Yeah, means here when we want to extract the data from the both the tables, Yes, we can, because we have common attribute in the table. That's why dependency preservation is there. And second rule is, the second one is lossless join. Means when you want to join these two tables, when you want to join these decomposed tables, you will get the original table. Your 100% it will come, because if you are using dependency preservation means that is nothing but you can join that. If you are joining the two tables means you can get the original table. Means when you are applying dependency preservation successfully, then automatically lossless join will come. Lossless join is nothing but after joining of these decomposed tables, you will get the original table. Yes, 100%. If it is a dependency preservation is there, automatically lossless join will come. Correct? Yes or no? Yes or no?
Yes, sir.
Are you clear about this? Problems related to the decomposition. All of you clear? Problem related to the decomposition. All of you clear? The first question is, do we need to decompose a relation? Before decomposition, we need to identify the normal form. The second question is, what problems does a given decomposition? One is dependency preservation, another one is the last lecture. All of you clear that? All of you clear this up to this? Hello?
Yes, sir.
Yeah. So the topics are schema refinement, problem caused by redundancy, decompositions, problem related to the decompositions. Now we are discussing about the functional dependencies. Today we are going to complete these functional dependencies so that we can go for the normal form. Here today's lecture is very important. If you are understood last class, here today's class is going to understand very easily. If you are understood today's class, the normal forms very easy. Here without normal form, don't expect database management system. That is why again I am asking, all of you understood yesterday's class? All of you understood this all? Schema refinement, problem caused by redundancy, decomposition, problem related to decomposition. All of you understood these topics? Then only I will go for functional dependencies. If you are really facing any problem of these three topics, again I will discuss. Don't waste the time. Quickly. All of you understood? Still any doubts here? Hello? Hello?
No doubt, sir.
Clear? Is this clear? Everyone, all of you must respond. Not only Anusha. I am not discussing with only Anusha. I am discussing with all. I am asking, I am expecting a response from all. All of you clear this?
Yes, sir.
Quickly. Okay, shall we discuss about functional dependencies? Shall we discuss about functional dependency?
Yes, sir.
Yeah, right. Very interesting topic. If you understand this functional dependency, then only we can understand. I am very clear telling, if you understood functional dependency, then only you can understand the normal forms. Again, I am telling, this is very, very important topic. Normal forms are completely depending on the functional dependencies. So if you go any interview or any technical examination, or if you go for gate examination, or if you go for anything,
Sir, can you explain once? Sir?
which one, Mohan? Which one? All topics. Hello? Mohan, you need all topics again. Okay. Okay, I will explain. No problem. Then whatever the exams, technical exams, if you are going to go through, if there is any DBMS question, compulsory it is from normal forms only. This topic only. Very important, please. Okay, Mohan is asking to repeat again. Here, this is not only for Mohan. I am repeating everyone. Please Understand the things, important, understand please. So now, schema refinement. I told you the schema is nothing but a table. Table is nothing but a, it contains a column. The schema refinement means any data you don't want to use, any columns you don't want to use, or if you wanted to having more redundancy, means same data, it is there more number of times. So now we want to avoid such type of data that is called redundancy. Here means you have to divide the table. To divide the table, that is called decomposition. To dividing of one particular relation into multiple relations is called as decomposition. When decomposition is required, when data, redundancy data is there in my relation, so that I need to decompose the relation. So that is called schema refinement. The schema refinement is nothing but you are going to modify the existing schema. Modification means you have to delete the column or add the column or update the column, whatever it is. That will be done with the help of decomposition. Why this decomposition is required or schema refinement is required? If your relation is having redundant data, as per our database management system, initially it will be developed only because of to avoid the redundancy. So that decomposition is required. Now understand everyone what is schema refinement and decomposition? Clear? Mr. Mohan.
Yes, sir.
Yeah, now, okay, because of the redundancy only, we have to apply the schema refinement and decomposition techniques. Decomposition means, already I told you, to divide the tables into multiple tables. Right. Then what are the problems will come for this redundancy? Yes, redundancy means same data we are storing multiple times. If we are using, if we are stored same data in a table multiple times, then what are the problems will be? Yes, we have wastage of the memory. The first problem everyone knows is the ignorance problem. If you are storing same data number of times, then that causes to redundant of storage, wasting of the memory. Here now the second one is the update anomaly. Here when I want to update one record, automatically another record is going to update because the data is same. If the data is same, means automatically the related data records also going to update. Already I showed with experimentally earlier. Correct? Sir, no. When you use update command, where age equal to 32, if we want to update, automatically all 32 ages are there, automatically it is going to update. Yes or no? If you are not using any primary key, automatically all 32 age students data will be updated. Yes or no? Hello? Hello?
Yes, sir.
Yeah, that is anomaly is nothing but a problem. Okay, right. Insertion anomaly. Here, when I want to insert, here, if you are not following primary key, then automatically the insertion means same data we are going to insert. Then deletion anomaly. Here, already I told you, when you want to delete one record, the same data which is having that record also going to delete. So that is the big problem. The same like that, if you observe one table which is an hourly employee relation, here if it is having hourly employee relation, here you don't go for the SSN and name, you go for these numbers. Then we can understand exactly the redundancy. Here this is the 35, 35, 35. Here we have stored 3 times. Here 8 3 times, 5 2 times, 10 3 times, 7 2 times. The 30 2 times, 42 times. Then like that, the data is redundant data is there. Yes or no? The data is redundant or not here? Hello? In this table, data is redundantly is there or not? Then you are asking. Again, I am explaining, but no response. How can I understand?
Yes,
In this
sir.
table, redundant data is there or not?
Yes, sir, there is.
Yeah. So that we need to refine the schema. When you want to refine the schema, we need to decompose the relation. Yeah, because redundant data is there. When you want to decompose the relation, specifically I told you that we need to identify the functional dependency. The functional dependency. The functional dependency, already I told you, one attribute is depending on another attribute. Here, one attribute is depending on another attribute, that is called as functional dependency. If you are going to observe LOT and rating, 48 is there, 8 is there, 22 is there, 8 is there. There is no dependency because 48 is there, sometimes rating 8, 22 is there, sometimes 8, 35 is there, sometimes 5. 35 is there, sometimes 5, 35 is there, 8. Means different values. There is no chance of functional dependency. Yes or no? Because rating is not depending on LOT. Yes or no? Yes or no?
Yes, sir.
Yeah. Now compare rating and hourly wages. Here 8 is there 10, 8 is there 10, 8 is there 10. Means wherever 8 is there, the hourly wage is 10. Wherever 5 is there, the hourly wage is 10. Compulsory means then you can understand this hourly wages is compulsory depending on the rating. Yes or no? Hello.
Yes, sir.
Right. Now again you check hourly wages is depending on hourly work. 10, 10, 40 or 40 or 30, not depending. Now rating with hourly wages also you check 8, 40, 8, 30. No, not depending. Even you check LOT with hourly wages. Okay, not performing. Okay, so that we have only one functional dependency. Here we are identified in the hourly employee relation, which is rating determines hourly wages. Yes or no?
Yes, sir.
Yeah. Now, here to avoid this particular redundancy, here, if we are not avoiding this redundancy, what are the problems will come? Redundant storage, update anomaly, insertion anomaly, deletion anomaly. Already I told you what is the meaning. If you want to update the record which is having rating 8, if I want to update, then what happened? Automatically, if I want to update this 8 related, for example, I want to update name of the this employee. Okay, Smiley to Raj. I want to update where rating equal to 8. What happened? I thought only this, but whenever I write where rating equal to 8, the 3 records are going to update. Yes or no?
Yes, sir.
Yeah, that is the problem. That is updated. If I want to delete this record also, 3 records are going to delete. If I want to insert something, you're already redundancy is there. So these are the problems with some and storage problem. Understand? All of you. Hello. All of you understood? Hello.
Yes, sir.
Yeah, these are the redundancy problems. So that we need to avoid this redundancy with help of decomposing of the relation. When I want to decompose, even before decomposition, I told you one more point also, null value. Here, whenever we are using here nulls, there is no chance of that redundancy. There are more null. If you write, you don't tell all nulls are there, sir, so that it's the redundancy. So null is nothing but there is no memory allocation. Yes or no? Null is nothing but not defined. If not defined means there is no chance of the memory. So that there is no chance of the redundancy. Understand?
Yes, sir.
So that we don't concentrate whenever the null is there. Don't think about there is a redundancy, so that I have to avoid. No, nothing, not required because there is no memory allocation. Okay. Now, if the table is like this, now I want to avoid this redundancy so that we can use the decomposition. Now, when I wanted to apply the decomposition, as I said, functional dependency is very important topic. We need to find the functional dependency. Then, based on this table, then what is the functional dependency here? Is there any functional dependency? If I want to decompose, what is the functional dependency here? What is the functional dependency here?
Hourly
Quickly.
wages depending on rating.
Yeah, hourly wages is depending on rating. So that we are identified. That is rating determines to hourly wages. Yes. So that we can take it these two columns into separate table and remaining columns into separate table. But when we are going to decompose a table, one column must be same in both the tables. So that very clearly the table is decomposed, the rating and hourly wages. There how many types of ratings are there here? How many categories of rating here? Tell me.
2 types.
2 only. 8 and 5. Yes or no? Hourly wages also for 8, 10 hourly wage, for 5, 7 hourly wage. Yes or no?
Yes, sir.
Instead of 5 records, we have written only 2 records. for 8, 10, for 5, 7. Here, remaining attributes, you can take it into another table. That is the hourly employee table. Now, this table contains redundancy. We cannot solve this redundancy. But anyway, we are reducing some redundancy with the help of this decomposition. Now, here, this is what exactly that decomposition. Clear, everyone? All of you clear this?
Yes.
Right. Now, after decomposition, we need to identify is there any problem of decomposition, because simply we are identified functional dependency and we are decomposing the relation. But some data it is going to lose after decomposition. Who is going to lose? Then the customers. For example, if it is financial data, banking sector, or any transaction data, if you are decomposed without any verification, yeah, sorry for the inconvenience. My side power, just now I connected through my mobile data. Okay. Is this clear? Is this clear?
Yes, sir. Clear.
Then we are going to decompose the relation. If there is a chance of loss of the data. To avoid that loss of the data, uh, uh, you need to verify that any problem is there for the decomposition or not. Yes or no? If you are not verifying, some record is going to be seen after decomposition. A lot of consequences will come. If the application is financial, maybe the lot of money is going to lost to the customer. So that we need to verify after decomposition. So any problem has came or not. Yes or no? Yes or no? Hello? Yes or no?
Yes, sir.
Yes, sir.
So that we need to verify problems related to decomposition. Now, how to check the problems after the decomposition? Here you need to ask two questions yourself before starting of the decomposition of your relation, because you are identified my relation is having redundancy and I identified functional dependencies also, then I want to decompose. But before decomposition of this, we need to ask two questions. So if these two questions are going to solve from your side, then go for the decomposition. The first one is, before decomposition, we need to ask first question. What is that? Do we need to decompose a relation? Means compulsory you need to decompose a relation. If you are going to decompose a relation, you need to find the which suitable normal form. Your relation is suitable to which normal form. Normal forms are there. Normal forms are depending on the functional dependency. Actually, today we have to learn functional dependency here because of some people are asking to revise, so that I am discussing. Here, next class we will discuss of the functional dependency. Because of the normal forms only, because of the functional dependency only, we can have the normal form. Means every normal form is having one category of functional dependency. So along with the different categories of functional dependency, we are going to learn the normal form. This way, here when we want to decompose, here before the decomposition, we need to ask yourself, do we need to decompose a relation? The meaning is you need to verify that given relation is suitable for which normal form. So that is what exactly we need to ask yourself. Means we have to find that relation is suitable for which normal form. This is very important. Means you must understand what is the functional dependency and which type of functional dependency and which is suitable to which normal form. Every normal form is going to propose one mechanism. That mechanism you must know, and you must be understand this given relation is suitable for this relation, so that only you go for the decomposition, because every normal form will tell how to decompose the relation. So every normal form is having some rules and regulations. Means first of all understand that normal form rules and regulation and how the normal form is going to tell to decompose. So that first understand normal form, so that you check the table. If the table is suitable for which normal form, you need to identify. After identification of the table related to the normal form, and based on the normal form rules, you have to decompose the relation. So at the time of decomposition, that normal form will tell here what are the functional dependencies related to that normal form. So that's why here the first question here before decomposition, do we need to decompose a relation? Means you are going to decompose a relation. You compulsory you want to decompose a relation. If you want to decompose a relation, you must be find the suitable normal form, which is suitable to your relation or not. So that is a very, very important question. Are you clear? This must be done before the decomposition. Are you clear?
Yes, sir.
Yeah. The second question is, what problems does a given decomposition cause? Means after decomposition. This second question is for after decomposition. The first question is for before decomposition. You are identified the normal form happily, and you are followed the normal form rules and regulations, and you are decomposed the relation. Okay, done. But after decomposition, you need to ask one more question yourself. That is, what problems does a given decomposition cause? After decomposition, is there any problem with these tables that you need to identify? Compulsory that you need to identify. Is there any other problem? What are the problems will come after the decomposition? There are basically two problems. One is lossless join, another one is the dependency preservation. First of all, we must understand dependency preservation. What is the meaning of dependency preservation? One after decomposition, maybe for example, one table is there, one table is divided into two tables. Sure, A and B. One table is A, B. You decompose it based on the functional dependency and based on the decomposition rules, and it is suitable for one particular normal form. You decompose it into A and B separate table. So these two A and B separate tables must be dependency preservation. Means B table must be depending on the A table, or A table must be depending on the B table. How it will become? Simple, you are implemented ER diagram. Students teach, faculty teaches to the students. The faculty and students is depending on students are depending on faculty always. So like that, customers borrowing money from bank. So like that, there's some dependency is there. That means when the dependency will come, when you are going to decompose a relation, there is a common column in the both the tables. Then only we can get the dependency preservation. For example, here Yeah, just now we decompose the relation, this relation based on the functional dependency. That is rating determines to hourly wages. Yes, rating determines to hourly. Rating and hourly wages is one table. Remaining all other table along with that one common column that is a rating. Yes. Now this is a dependency preservation of this table. Now what happened here? Here, this is a dependency preservation of table. Here, this hourly wages is come from the wages tables with help of this rating, so that we can get the dependency preservation. Are you clear now? Are you clear now?
Yes, sir. Clear, sir.
Yeah, these two tables are having dependency preservation. Yes or no? Yes or no?
Yes, sir.
Yeah, now our decomposition is right. Second question is the lossless join. That is the second question. After decomposition, you need to ask yourself, that is a lossless join. What is the meaning of lossless join? Means when you are going to join these two tables, you must get the original table. When you are going to join these two tables, you must get the original table. So that is called as lossless join. Means when you are joining, no record is going to lose. That is what exactly the intention of lossless join. After decomposition, you need to check this lossless join also. If the lossless join is going to satisfy and dependency preservation is satisfied, your decomposition is right. If any condition is going to fail, your decomposition is fail, so that you use original table instead of decomposition tables. So that here these two tables again you need to check join. Here when I wanted to join, there is a decomposition preservation. Here what is that? Here one common column must be there. When I am going to join using this column, 100% I will get the original table data. Yes or no? Yes or no?
Yes, sir.
Because wherever the rating 8 is there, 10 will come automatically. Wherever the rating 5 is 7, automatically will come. So that total data will come as it is like your original table. So that we can get the lossless that. Means one point you can understand here based on this knowledge, there are always uh, lossless join depending on the dependency preservation. The dependency preservation is not based on the lossless join. So that's why if you are going to really work on dependency preservation is satisfied, then no need to worry about the lossless join. Correct? Yes or no? Yes or no?
Yes, sir.
Now understand these two questions related to problem related to decomposition. That is, do we need to decompose a relation? What problems does a given decomposition cause? Now understand everyone?
Yes, sir.
They're not only understanding, at the time of decomposition, we need to check compulsory before if you are applying normal form. At the time of normal form means normal form is nothing but it's a technique for decomposition of table. Don't think normal form is something. Here, normal forms are nothing but those are the techniques to decompose the relation. Every normal form is having some rules and regulations. So that normal forms are nothing but those are the techniques to decompose the relation. Means here when you are going to decompose the relation, the first question is you need to check which suitable normal form for this relation. And after the applying of decomposition with help of the normal form, so then you have to check post decomposition rules. What is the post decomposition rules? It is a dependency preservation and lossless join. Understand? This is every time. Which normal form you are going to apply after normal form. Before the normal form application, you need to check this question, and after the normal form application, you need to check this question. These things are continuous process. This decomposition questions are continuous process when you are going to apply any normal form. Clear? All of you clear?
Yes, sir.
Yeah. So remember this. Okay. Right. Now time is very less. Uh, we will discuss these functional dependencies. At a time, I have to discuss these functional dependencies so that only you can understand. Okay, before that, at least we must know the what is functional dependency. So what is the functional dependency? So just now I showed here functional dependency is nothing but one in a table, one particular attribute depending on another attribute. Here we need to find those categories of attributes in a table is called as functional dependency. Here in this table especially, hourly wages is depending on the rating, that is called functional dependency. Here why functional dependency is required? Tell me any one of you why functional dependency we need to identify in a table. Why should we identify? Hello? Why should we identify functional dependency in a table? Hello? Are you there? Why should we identify functional dependency in a table? When I am asking question, John is going to left. I don't know why. Any one of you? So just I explained 1 hour. I revised 1 hour things also. You in order to decompose a table exactly. Sure, why you people are not responding? Only one or two people are responding very slowly. Okay, exactly. When you want to decompose a table, compulsory we must know the functional dependency. Why? Because when you want to decompose a table based on the functional dependency only, we are going to decompose the table. Yes or no? Yes or no? Hello? Yes or no?
Yes, sir.
Yeah. Sure. So that we must know the functional dependency. Here we have so many functional dependencies formulas. Here, as per your mathematics, if you know really the mathematics, these functional dependencies you can understand very easily, and mathematical formulas only we can use here. Okay, the functional dependencies are there. They are based on the functional dependency. We can identify the functional dependency. Based on the functional dependency, we can apply the normal form. That's right. Before going to the normal form, we must understand functional dependencies with example. So that if you want to understand functional dependency, why functional dependency means, that this topic again I revised today because functional dependencies are very important. Even in examination, your placements also they are going to ask directly these questions. And even in gate examination and other technical examinations also they are going to ask. So that I explain again. And functional dependencies are very important. Really, if you are understand the functional dependency, how to identify the functional dependency, normal forms are very easy. You can easily understand and you can easily solve the problems for in your database management system. I am telling again, without applying of normal forms, so your database is not a database management system. Your database again it is a file management system. Because if you are maintaining the redundancy means unnecessary, here you know 4 problems are there. If these 4 problems are there, automatically it is not a database management system. So that whenever we are going to learn whatever the topics we are learning slowly, all these things you need to apply your database. Enough is clear. Till now we are created databases. You people have created databases, but you are not applied any decomposition techniques for normal form. Once you learn one by one, then directly you need to apply those things into your database so that your database will be good. Otherwise, your database again these problems are there. Again, it is looking like a file management. Are you clear? Are you clear?
Yes, sir.
Yeah, I will show you one by one normal form from the next class onwards. Here, if you are understand this topic, then you check in your database. What are the tables are there? For every table is suitable for which normal form. If it is suitable for that normal form, then you need to apply that normal form and decompose the relation. That is your duty for your database. That is your third experiment as per the laboratory. So that parallelly you work along with me for the third experiment so that you can finish that experiment also. Clear?
Yes, sir.
Don't think again we need to discuss again the third experiment again.
because anyway we are doing this here. Same thing you can apply there. Automatically your third experiment will be cover, and you need to work out on your database, and you need to update your record and observation parallelly. Clear? Clear? Because if you are practicing on your database, then you can understand normal form very easily. If you only follow my lecture and just listening, understanding, it will be help a problem. It is a problem for at the time of application. So that whatever you are learning here, you need to apply to your databases. Then you can get more clarity, so that you can understand very easily, so that you can solve any problem based on the normal form. Understand? So learn application orientedly. That is what my intention. Clear? All of you clear?
Yes, sir.
Yeah, please do it. So now I think everyone is understood today's topic, so that I can continue in the next class functional dependencies, right? Right?
Yes, sir.
Yes, sir.
Yeah, please, next time onwards, if any doubt or any clarification is required, you ask in that class only, so that we can't waste our time and we can proceed the things. Okay? Is it okay?
Okay, sir.